Now for the previous video finding square root by linear searching process, we didn't use prototype. Now we have used prototype like this. Now it's look much cleaner and sharper. And in the previous video we didn't use lower limit and here and upper limit here. We used 0 and value. If we use lower limit, if the program is less than 1 and greater than 0, 0.4, then it also computes. So this is our new adding things, and voila, this is done. Thank you. Assalamu alaikum. So now we will talk about binary search, the second process. Binary search is more faster than linear search if these things are sorted. So as we can see, this square root of function, this thing, we input a value, then we get the answer. So suppose we have value we have value 5. So 5, we start from 0, then we will end in 5. So we are going in a sorted way, lower to upper. So if we use binary search, it will be more precise, like this: 0 and 5, the middle point term is 2.50. if we square this thing, or if we multiply this thing with this same number, then it will be around 6.25. So here this is 6.25. obviously if there is a number between here to here, it will always be greater than 5, so we can skip this thing. Then we can again find the midterm of these two is equal to 1.15, and again we will multiply this thing with this same number. Then we can see that it becomes 1.25 into 1.25, approximately 3 or something like that. So we can skip this thing because we have underestimate we have underestimate, and here the previous thing, previous part, we have overestimate. So we can again skip this thing. By doing this type of thing, if after finding the midterm and again multiply it by them the middle term again with itself, we can find the value much faster if things are sorted. In this binary thing, we have to use double guess this formula, like this: double guess equals to lower limit plus upper limit divided by 2. Here we have done this thing. So every time it is half. Every time the process is less than half or reduced. The code is this code is similar to the linear, so we have to copy paste lots of things. So I have a notepad here. I have to copy these things, like function with a binary. Here I have written this thing: compute square root with binary search value. Here you can see LF long float, that's represent this value, and that's represent result V. So we understand that. And also we have used double abs value. We will see it will be needed in sometimes. Now first of all, we copy paste. We have copy paste the linear search. Here we will change this thing with binary search. Control X, not Control X. Compute this thing. Control C, Control V, Control V. Then these things will be the same as before. This whole part will be the same. Here we can see we used for linear search, but we are using binary search, so we don't need for loop. We will be needed while loop, as we don't as the initial and the final value changes, so we don't have the exact or definite value, so we have to use while loop here. While is always true, so we will use while is always true. Then we will be using this thing like this. Wait, we will change this with this thing, Control V. Now it's good to go, and this thing will be the same as before. And here we will use if condition, if condition, like here. If the f's value is like this, here we will use else if condition. This is if, so if we use this condition like this, else if error is greater than 0, then upper limit will be guess, and else error is less than 0, then lower limit will be the equals to guess. And in the previous we have used the f's error is less than or equal closeness, then we will use this thing. Also here we counting number of guesses and then return guess for. Then now we haven't used the prototype. We can use prototype like this, Control V, semicolon, Control V, Control C, semicolon. Sorry, yes. Now if we run this program, it is running. 5 is equals to number of guesses is 0. Then 9 equal 4. No, it is previously there was an error in here. We didn't included this. This is an important thing. We have changed the guesses system only. In the previous I have shown you like this, 0, if we count 5, 0, 2, 5, we initially guessing the middle term, then square it, then minus this guess into guess from this value. Then we are saying if it is plus, then we are overestimating. If it is minus, then we are underestimating. So we are reducing every half every move. So that is why while is used in binary search. Thank you. And we have also used the prototype. There is nothing here to update. And also this thing is like linear search. We have used, nothing changed, only this part has changed. Here also the double guess equals to this formula we have used, an f's error, and also we have used if else if, because here while loop, so it is important to include these things, or else we will get only the limited value. So thank you.